Hello everybody, my name is Widodo Wijaya Basuki from Atmajaya Catholic University of Indonesia, and today I will present you our research activity with the title Experimental Study of Biomass Gasification in Reactors with Vacuum Pressure. It is a joint collaboration between Universitas Subang and Atmajaya Catholic University of Indonesia, and this research is supported and funded by Ministry of Research and Technology Ristek Republic of Indonesia. The research team consists of Mr. Mukhtar Kosim, Mr. Novandri Trisetiyaputro, Mr. Denny Poniman Kosasi from Universitas Subang, and Ronald Subwadi and me, Widodo Wijaya Basuki from Atmajaya Catholic University of Indonesia. As everybody know that the most used energy resources are fossil fuels, and fossil fuels are not renewable. So therefore, we will face a big problem in the next decades because fossil fuels will be exhausted. The second problem is if we burn the fossil fuels, the carbon trapped in the fossil fuels will be released in the atmosphere in the form of carbon dioxide. It can increase the greenhouse effects and the global warming. Therefore, it's important to change the conventional power technology to the new one, which can use more environmentally friendly renewable energy resources. Indonesia, as an agricultural country, has a lot of renewable energy resources. Among others are biomasses. This energy resource is easily available and can be found in the agricultural waste products such as rice husk, coconut shells, and etc. In this experiment, we will use coconut shell and rice husk as the feedstocks for our gasification system. The biomass gasifier used in this experiment is the concurrent flow gasification system, in which the air flows together with the biomass in the reactor by means of suction from the eductor. The concurrent flow gasification system is much stable and much safer, incomparable to the conventional gasification system because no high pressure will be produced in the reactor and in the piping system. So the concurrent gasification system is not vulnerable to explosion. Biomass in the reactor will be combusted by utilizing the oxygen from the airflow to produce carbon dioxide, water vapor, carbon tar, and heat. The heat will be used to raise the temperature in the reactor such that the gasification reaction process can be hastened at a temperature above 800 degrees C. In the gasification reaction process, the carbon will be react with carbon dioxide and water vapor to produce carbon monoxide and hydrogen. Both of the gases are the component of the synthesis gas. The high temperature synthesis gas above 100 degrees C will be cooled down in the cooler to below a temperature of 40 degrees C, and then the tar will be separated from the gas in the filter. The gas will continuously flow uh, to the chimney, and there it will be burned to produce flame. This flame is an indication that the synthesis gas was produced in the gasification reaction. In the other case, the synthesis gas can be used uh, in the 5 horsepower generator engine to produce electricity. In this experiment, the temperature in the reactor will be measured in the inner wall of the reactor to ensure whether the insulation layer is needed. If it's needed, that it should be investigated the thickness of the insulation layer. Therefore, uh, the first investigation is the investigation of the reactor properties with and without insulation layer. With the insulation layer, we can see in the left diagram that the temperature profile in the reactor increased rapidly from room temperature to about 400 450 degrees C for both kind of biomasses, and the temperature stay constant at 450 degrees C, and this temperature is too low for the gasification process, therefore no flame can be recognized on the chimney. For the reactor with 30 millimeter insulation layer, we can recognize using the rice husk as biomass. The temperature increase continuously to 1050 degrees C, and this temperature is too high for the material of the reactor, so therefore the combustion process have to be stopped. The flame can be recognized at 800 and 990 degrees C. Beside this temperature, no flame can be recognized. That means the synthesis gas production was not stable. Using coconut shell, the temperature rise from room temperature to 800 degrees C and stay constant for 30 minutes. And here the synthesis gas was produced already at a temperature of 622 degrees C and stay stable till the end of the experiment. From this diagram, we can also recognize that the temperature reduced from 800 degrees C to 500 degrees C. This is a risk for the stability of the syngas production. Therefore, we have to increase the thickness of the insulation layer. The next investigation, we use three kinds of insulation layer thicknesses: 30 millimeter, 80 and 130 millimeter. In the left diagram, we can recognize that the temperature reduction reduced with the increasing of the insulation thicknesses. To better investigation of the temperature drop, we can see the diagram on the right side. Here, by adding a 50 millimeter insulation layer, the temperature drop reduced from 300 to 200 Kelvin. That is a delta. That is a temperature drop difference of about 100 degrees C. By secondly, adding a 50 millimeter insulation layer, the temperature drop reduction is just about 26 Kelvin. If we look at the dashed line, that is the temperature reduction rate curve, we can see by the second times adding a 50 millimeter insulation thickness, the temperature reduction rate is negligible small. This means that it's not possible to maintain the temperature in the reactor to 800 degrees C without to change the insulation material. The next experiment is to use the synthesis gas in the generator engine to produce electricity. The synthesis gas is able to generate a maximum current of 2.1 ampere with a maximum voltage of 218 volt. The electric power is calculated to have a value of about 457.8 watt. This electric power is enough to light three light bulbs with each input power of 100 watt. Using this generator engine, this generator engine is able to be run for about 25 to 30 minutes, but by ever decreasing electric power. This is caused by the heat in the reactor, which is not able to be maintained, so that the temperature in the reactor will decrease below a temperature of 800 degrees C. Thank you very much for your attention.